Okay, so our new lesson for a little while is going to be systems of equations. Okay, it sounds like it would be something that's very difficult. Some things will be difficult if you don't pay attention to what's happening at the very beginning, because the beginning is the easy part. Okay. So system of equations just means that we are comparing more than one graph of a line together. Okay. So if we're looking at a graph of a line, we've talked about how to determine the slope and the y-intercept, right? Okay, so if you're looking at this graph, what type of slope is this going to have, positive or negative? Okay, so this one has a positive slope. And what type of y-intercept does it have? It's also positive because it crosses above the origin, right? So it has a positive slope and a positive y-intercept. And if we were to try to guess what that equation looks like, we know that it's going to take the form of y equals mx plus b, right? And we're going to show that the slope is positive and that the intercept is positive. We don't have any units to reference right now, but we do know it's going to look something like this. And so if I look at another graph and it's going this direction, what type of slope is that going to be? Okay, so now we have a negative slope with what type of y-intercept? With a positive y-intercept. Okay, and so the equation of this one would be y equals a negative mx plus b. We just know that the slope would be negative and that the intercept would be positive. Now, there is a point where we could graph two lines simultaneously, meaning at the same time. So let's say we have this graph of a line and this graph of a line. Okay, so we have two lines, and what's happening with them? They intersect each other. All right, and so that's how you know what the solution to the system is. The system is these two lines, and the solution is where they intersect at. So solutions are where they intersect. If they intersect, how many solutions are possible? How many times is it going to intersect? Are there any other points where it's going to intersect at? Yeah, it's only ever going to intersect once. So this is one solution. So what would you call it if I gave you a graph with a system that looked like this? Those are definitely parallel lines, right? And what would we say about the solutions? Now remember, I said a solution is where they intersect. Will these ever intersect? No. A part of the definition for being parallel is that they'll never intersect, right? So how many solutions? No solution. Later on today, you're going to do a quick practice over this, and you're expected to, if you're typing in the answer, you will type this entire phrase. No solution. Okay, and there is one other. We did one solution, we did no solution. What's the next example going to be? So we're anticipating infinite solutions. Okay, so here's our graph. All right, and there are two lines here. This one and this one. What does that mean? I graphed the same line twice. And if I graph the same line twice, that means that they intersect everywhere, right? And if we have one line that's been graphed twice, it's still the same line. How many solutions is it going to have? Infinite solutions. So one thing to look for if you're just looking at a graph, and it only looks like one line and they're telling you it's a system, that means that it's the same line twice, which is infinite solutions. Okay? And so I would put myself a little star here. It's the same line twice. Okay.